Yeah, I was talking with Taylor earlier tonight, and this came up, this whole prompt engineering. Now, I have videos on this. I think you can search. Can you search? Yeah. Okay. So here, for those of you that are just listening, that aren't watching this, in the search on Goju Tech Talk, I have a few videos on prompt engineering. First one, prompt engineering, nah, just more hype. But is prompt engineering actually engineering is the second one. I guess it's only two, but then there's a few more that popped up that I think also talk about prompt engineering. In a nutshell, if I can explain this maybe the fastest that I possibly can, let's actually have Google fact check me. What is engineering? All right, let's see what Google says, and let's try to compare and contrast this with the universe of prompt engineering. All right, what Google says engineering is this. It is the application of scientific and mathematical principles to design, build, and maintain structures, machines, processes, and systems. It involves problem-solving, innovation, and practical application of knowledge to create solutions that benefit society. Engineers use their understanding of science and mathematics to develop new technologies, improve existing ones, and solve real-world challenges. And then it explains some more of this stuff. Notice, if you will, two key important properties of engineering are that it is the application of scientific and mathematical principles. I pretty much agree with this. The way that I describe it is that engineering is the process of applying knowledge that we have a priori, that we've learned through scientific experimentation and logical reasoning, that will give us predictable outcomes that we are going to rely on to build things. The predictable outcome part is super important. This is what makes it engineering and not astrology or tarot card readings. Okay, those things are less predictable. And if you like those things, that's cool. I like those things too. But I don't want those things. I don't want tarot cards and astrology to be the foundations of a bridge between the West Coast Peninsula and the East Coast Peninsula in Northern California. I think that would not be super great because I don't think that bridge is going to stand. I think it's going to be imaginary, and lots of people are not going to survive driving on that bridge. For bridges or other things related to engineering, like airplanes and computers and all this stuff, I would like to have them be based off of science that is far more deterministic, it is reliable, and that we can trust. So then when we get a result, we can rely on that result, at least for the most part. It becomes a nines problem. Like it's 99 point how many nines reliable. For the most part, airplanes are very reliable. I realized recently there's been a tragic accident with a plane going down. My heart goes out to all the people that were involved in that, either on the plane or the families. It's heartbreaking when these things happen, and we need to do a better job trying to make these airplanes and other modes of transportation safer. And that is going to go to engineering. It's going to do more with us getting things more reliable, right? Now, is creating a prompt for a machine learning system, a large language model, the application of scientific and mathematical principles? It is not. And the reason why it is not, and I don't mean to sound like I'm the knower of all things, I just mean that based on this definition, which I think is a pretty good definition, The reason why prompt engineering is not this is that it is not the application of scientific or mathematical principles. That's not what writing a prompt is for a language model. Writing a prompt for a language model is putting in a whole bunch of written prose in a variety of ways and hoping, crossing your fingers, that you'll get a specific outcome. That's what it is. It doesn't really go much further than that. And the reason for this is manifold. First, that language models are stochastic machines. So even if you had a perfect prompt, because the language model is stochastic in nature, there's no guarantee that prompt that you give it is going to give you a deterministic answer. But that's what you need with engineering. With engineering, you need things that are reliable, right? That like chemical engineering is a really good one. Imagine if you had two chemicals that you're going to work with, and once in a while, when you combine them, things just blew up. Do you think people would fiddle around with those chemicals? I mean, the likelihood, I think, is pretty slim. It might happen, but it's probably going to be less safe. The beauty, though, about chemical engineering is that the chemicals have very reliable properties when they're combined, for the most part. It's not perfectly deterministic, and a lot of that, I think, probably has more to do with limitations in the knowledge that we possess as a species on how the chemicals work than sort of random magical events that happen that cause bad behaviors. What I mean by that is there may be cases where unexpected results happen when you combine chemicals that are supposed to play well with each other, but they might not. But that outcome may have less to do with the chemicals behaving in an unpredictable way and more to do with an environmental change that was undetected, people were unaware of, and then that caused things to go in like a bad direction. I'm not saying that this is always the case. There are cases of uncertainty in like the knowledge that we possess with these properties, but there's other factors is I guess what I'm talking about. For the most part, we can largely depend on these things doing the things that they're supposed to do. Like, for example, if I have some code, let's use software engineering, since software engineering is, I think, a really good vehicle for this. We'll just look at C++, since it's my favorite language. I'm sorry if people don't fully love that. And this is our staging server, so if things are going in a wrong way... Oh, there we go. Okay. Now let me show you what I mean about engineering and what engineering kind of looks like, and why you want it to be deterministic, and why this is engineering and what you're doing with prompts is not engineering. Okay. This is engineering because this if statement, if right is false, it cannot enter this control expression. It cannot ever go this way. It must obey this. It can never go inside of this. I don't know, this probably sounds like it's a broken record, but I'm trying to be super clear, is that the laws of the universe say that only when right is true are you allowed to go in here. That means that only when right is not true, it will go in here. Now imagine, if you will, that you're running this program and then just one out of every, let's say, million times, it decides, I'm going to go in here when right's false. No big deal. I'm just going to do it once out of every 10 million tries. Like, largely, it's doing the right thing. What could happen in that one case? What does that happen? What does that result in with the user experience? What about the developers? How do developers debug this? How do they make this stop happening? So you get the user report that there's this bug and it went in here, and you're looking at this code saying, well, the code looks right. And you're like, I don't think there's a bug here. And then you say, oh, that's right. It's stochastic though. Shoot. That's right. We used a stochastic system. And so once in a while, right could be false and go in here. Well, Bob, I guess we got to deal with that. That's what you have. And that is not engineering. That's not how engineering works. Engineering works based off of scientific and mathematical principles that are going to give us deterministic or largely deterministic behavior. I say largely because there's some cases where variables are outside of our control. Like, for example, if this has some kind of weird memory overwrite that right comes in, where is right? Right comes in here, and right is true, and then somehow one of these operations flips right to right is false. Now, this code will still do the right thing, but if you looked at the value of right here, you would see, oh, it's true. So it's going to go in here. And you put a breakpoint, and then it doesn't go in here, and you're like, wait, what happened? Well, it turns out this FD set, this file descriptor set, actually overwrote into this right because somebody mismanaged the size or something of this FD. Okay. Now, that could happen, but notice that that doesn't change the fact that this has to be correctly checked. What I'm talking about with these stochastic systems is that you can have this check and it can say, yes, right must be true here. And then it can be like, but this time we're going to let it fly. So right is false. And it's like, go ahead in anyway. What the heck? That's not going to work as far as foundation of engineering. That's why prompt engineering is not engineering. It's something else. I'm not sure exactly what it is, but it's not engineering. And I think that people are doing themselves a big disservice by calling it engineering. But check this out. We're going to go down this rabbit hole a little bit more, hopefully until I'll just keep fighting this battle. I think I was telling Taylor on the phone tonight, I'll probably fight this battle until either people stop calling it prompt engineering, which will probably happen at some point, or I die. One of those two things. And I've gone down this path before. There used to be this thing called software 2.0, and thankfully we stopped using this term. And instead, we started using this term machine programming. And we wouldn't use software 2.0 because it just was sort of nonsensical. And at the time, people were like, well, this is crazy. This is an interesting fight to draw a line in the sand on. And I was like, well, it has to do more with the fact that software 2.0, one, doesn't make logical sense to me. There's no universe where I see all software being written all from a bunch of numbers that can't be reasoned about logically. And on top of that, it's using systems that are stochastic, and I don't know how that can give us reliable software. And then the third piece is that who says we're just at version 2.0? What about the 70 years of work that people have done in computer science and with software prior to this? Does that all not count? It's just like, it's whether its intention is or not, it's really a dubious thing to say because of sort of the arrogance around it. It's very arrogant to suppose that a neural network or neural networks will replace all software code, and then all the software we had prior to neural networks is 1.0, and everything moving forward that's neural networks is 2.0. Keep in mind, I teach neural networks at the universities, so I love neural nets. I'm a huge fan of neural nets, but they're not a panacea. So I would die on that hill, and I literally was dying on that hill, and thankfully we stopped using this term, mostly because I think people came to their senses and they're like, oh yeah, that makes a lot of sense. This is actually a really bad term. Similar thing with prompt engineering. It's not engineering, guys. Stop calling it engineering. You're making yourself look bad, and you're hurting your reputation. Let me explain why. The first is you're making yourself look bad because people are not stupid. They're gullible, but they're not dumb. And they also know how to use computers and Google things like what engineering is. And so when you call this prompt engineering, and they're like, it's engineering. And then their partner says, well, what is engineering? And then they get on their computer and they look it up and they're like, wait a second. So prompts, though, don't necessarily use knowledge that we have to create solutions that benefit society. Like, that doesn't feel like that matches. And also, when I'm doing prompts, I'm not necessarily using science and mathematics. So this is weird. It doesn't feel necessarily like this is. Again, going back to why this is engineering, it's using science and mathematics. This is logic. Logic is the foundation of mathematics. Like, mathematics sort of comes after basic logic, at least in my mind, that you have things like first order logic and predicate calculus, which is things like this and this, or you have something like this or this. And then you introduce things like for, excuse me, for all x's, there is some x that exists that is equal to some y, something like that, right? These are things that you learn in first order logic. And this here is first order logic because it's, well, I guess it's mathematics, but this is first order logic because it's using the and that we just talked about. It's saying this thing and this. So while these things are the cornerstone of mathematics that we think of, I think, in a traditional sense, like the less than operator or equality, these logical operators, I think, are actually precursors to mathematics. For some reason, we like learn these things later, like at the collegiate level. I don't know why that is, especially given that we do learn what and or are in grade school and like before high school. But again, a part that's going to make this even stranger is, and this is maybe just in the United States, but what we often learn in school prior to collegiate learning of first order logic is this notion that when we use the word and, we mean the logical and. So go to the grocery store, get bread and milk. Yes, that is what and means here. But interestingly enough, when we get into the or operator, I suspect I'll find an or operator in here somewhere. I don't think I'd have to look too far. Here's the or operator. We generally mean exclusive or, not inclusive or. This is inclusive or, not exclusive or. And the reason why is that what we mean when we generally say or in normal things is this or that. Well, dear, you can have popcorn or you can have ice cream. Which do you want? What we mean in first order logic with inclusive or is either can be true or both can be true. You can have the popcorn and the ice cream. The exclusive or is the or that we use in normal conversation. It's one or the other, not both. So do you want the popcorn or the ice cream? You can only have one. And that actually is why we call it exclusive or. It's you can have one or you can have the other, but you cannot have both. It's exclusive to each one of these. An inclusive or is basically saying that no, it's inclusive. So either of these at the same time is fine. You can have both. So in code, when we say or, what we actually mean, and this maybe is something that maybe you haven't learned in school. I don't know if many people talk about this, is people will learn or and then they'll learn exclusive or. What we really mean here is inclusive or. And then when you think about it like this, there's two ors. There's the inclusive or, which is that guy. And then there's exclusive or, which is a different guy. And so when we say or, in the traditional sense of these operators, there's the silent inclusive. Excuse me, my throat's, I guess I've been talking too much today. So I find this at least slightly amusing in that we don't say inclusive or, we just say or. It kind of makes sense. But I think when people learn exclusive or, they get confused, or at least a lot of people that I've taught exclusive or, they get confused. They're like, oh, XOR, it's XOR, so it's or it's XOR. And then many people don't know the X stands for exclusive. And so again, this is going back to the whole mastering the basics. If you just master the basics, a lot of this stuff just illuminates itself. So when you understand XOR, the X stands for exclusive. And then you think, what does exclusive mean? Exclusive means one or the other. So like a mutex, like a lock, is a mutual exclusion. They cannot be both active at the same time. It's mutually exclusive, meaning only one of these things can do this at a time. Mutex. So XOR is the exclusive or, and so they can't both be at the same thing. So it's the same principle. Mutex, the exclusive part, exclusive or, exclusive part. Same principle. Same principle. And now, when you think about XOR, it's probably like, oh, right. Yeah, it's just the exclusive part. And then when you think about normal or, there's the silent inclusive part. And so hopefully this has made your life a little bit better. Is that now you can look at code in maybe a slightly different, more deeply nuanced way and start to ask yourself really interesting questions like, what about and? And I haven't thought about and its exclusivity or inclusivity. I think by default, based on the properties of and, it has to be inclusive in the sense that you kind of need both things to be true simultaneously. So I don't know that you can have an exclusive and. I mean, we'd have to think about this a little bit more. This is just sort of my very quick treatment of this. But hopefully, if nothing else, we've learned a little bit more about programming and the silent inclusive that's in front of all these OR operators. So given all this, our discussion about what engineering is, and it's based on the principles of science and math, and now we go back to this thing about prompt engineering. It's my hope that you can see that's not engineering. That's something, but it's not engineering. Now, you may be asking yourself this question. Why do a lot of these big vendors and trillion-dollar companies or whatever keep calling this prompt engineering, and they're encouraging people to do this? I have some thoughts on this. And I don't want to promote this idea of thinking people are bad actors. And I want to continue to push the narrative of I'm going to foster goodwill. But I do want to share that there is this interesting side effect that could potentially be happening, which is if enough people start doing prompts that they're specifically testing with, pick your vendor favorite, your favorite vendor's company. So we'll say Google, Microsoft. I'm not even gonna list this one that I'm not a super fan of. Anthropic, Amazon, Meta, so on and so forth. If you notice that there's one, oh, sorry, IBM, my bad. There may be a big one that I'm leaving off, and it's not X, by the way. I'll even add X for its, what is it, Grok or something? There is one on here that I'm not listing because I feel like they're being such bad actors. I'm not even going to talk about them anymore. That's my way of not saying something nice. They won't even get their name on this channel. I'm really not super impressed by the stuff that they've been doing. But and they're definitely leading the charge on promoting this in a not super great way. But for these other guys, you can imagine that if you are creating prompts for their language models, what are you really doing? What you're doing is, in some sense, you're writing code for them that is, I mean, it's not even reliable code because it's not deterministic, but if it were, it is likely going to give you the answer that you want specifically for their system. You're essentially writing proprietary code that's not code, that is only sort of guaranteed to work with Google or Microsoft or IBM or Anthropic or Amazon or Meta or X, and so on and so forth. Why would you do that? Why instead would you not write something that is not proprietary, that will function across all systems, like actual code, like C++ code or Go code or JavaScript or TypeScript or something else that is not owned by a specific company, that is solving a problem that is going to be specifically reliant on their language model? Because even if your prompt does work really well for Google, I can pretty much guarantee you that prompt, when you try to take it and use it on something over here or over here or over here, your answers are going to be different. And here's the real question. Who does that benefit? Because it doesn't benefit you. It's more work for you. But does it benefit them? Like, think about this for a second. You write this prompt and you have all this stuff that works really well with just Gemini or just Copilot or just Claude, just Llama, just Grok. And then you try to move to one of the other ones and it doesn't work anymore. What does that do to your life? Well, I guess you are a single vendor customer now. You can only work with a single vendor. And guess what? They now have cloud lock on you. They've wanted to do it for a while, lock you into their cloud. Now they've just done it. And they've done it in a really clever way that's probably not even something you're thinking about. You just signed your life away to where now they are your perpetual cloud vendor. I don't think that's good. I don't think you want to do that. I'm fighting for you here. I think you want to be able to use any of these systems, and you should build solutions that will work with any of those systems. And it's not by interfacing directly with them using their prompt, whatever. It's probably by building a layer of abstraction between you and them, and then building different interfaces that are aligned with working with their stochastic systems, and they change each time. But you function at this level here that does not interface with them directly. This is computer science 101 stuff. You're adding a layer of abstraction to abstract away the specificity that's built into these. Now, the upside of prompt engineering for them is don't use those abstractions. Not because you wouldn't build more resilient software. You would. You would build far more resilient software. If you don't believe me, just like Google, why is programming using abstractions? Man, helpful. Oh, I was actually going to look at the inverse. Abstraction of programming simplifies complex systems by focusing on essential features and hiding unnecessary details, making code easier to understand, manage, and reuse. This allows developers to work at a higher level of abstraction, focusing on what rather than how. Yes, the what rather than the how. The what is we're going to try to build this thing. This is the what. This is the how. Let them figure that out. You focus on this. And so you're going to function at this level, not at this level. And then that's going to give you a solution that's potentially portable. This is also why you generally don't program directly at the operating system level, because you don't want to be bound specifically to any OS. You want it to work on Windows, on Linux, on Unix, on Mac OS, on all this stuff, on Android, on iOS. So you program at a higher order abstraction. For example, Mentor runs in your browser. Why? It's portable. It's portable. It can run on all these different places. As long as you have a browser, that's all that it really cares about. This is sort of not an accident, right? So do the same thing. Don't buy into the propaganda, which is programmed directly against our model, because the more I think about it, the more at first I just thought people were confused. Again, I'm going to still try to foster goodwill as much as possible. For a while, I thought people were just confused. I was like, why do you guys keep calling this engineering? It's not. It's prompt something. And then they just kept doing it. And now I'm starting to think that I'm the one that's clueless, that they knew this whole time that it's not engineering, but by selling it like engineering, that somehow this is like some magical thing. Like, look, I'm a prompt engineer. I do all this stuff. Really, it's giving them a vehicle that is allowing them to present this as like fostering goodwill. Oh yeah, you got to be a prompt engineer, and they can all rally around it. And really what it's doing is it's binding you to their specific APIs, their specific cloud, which is a big, I mean, do you notice something that's kind of in common here with these guys? Google makes a huge amount of money on their cloud. So does Microsoft. I think IBM not as much. Anthropic, that's pretty much their entire income. AWS, Meta has got some plans for this. I'm fairly certain. We don't generally know, I think, the n-dimensional chess that Zuck is playing at all times, but he's playing it. I can pretty much guarantee you. And then similar thing is happening over in Elon Musk land. So the takeaway here, not engineering. It's prompt something. And when you do this directly at the language model level, likely the only one that benefits are these guys, not you. So maybe don't do that.